Hello, I am going over a TED riddle today. I thought I'd do something fun and try and do some coding with it. So this one is called, Can You Solve the Leonardo da Vinci Riddle? So let's watch it.
You've found Leonardo da Vinci's secret vault, secured by a series of combination locks. Fortunately, your treasure map has three codes: 1210, 3211000, and the last one appears to be missing. Looks like you're going to have to figure it out on your own. There's something those first two numbers have in common. They're what's called autobiographical numbers.
Okay.
This is a special type of number whose structure describes itself. Each of an autobiographical number's digits indicates how many times the digit corresponding to that position occurs within the number. The first digit indicates the quantity of zeros. The second digit indicates the number of ones. The third digit the number of twos.
Okay.
And so on until the end.
Sure.
The last lock takes a 10-digit number, and it just so happens that there's exactly one 10-digit autobiographical number. What is it?
Okay. Oh, that's it. Okay. I think I could use some coding for that. Okay, cool. So this is I haven't seen this one before, by the way. So this is all new to me. The number must have 10 digits. First position indicates how many times 0 occurs. So this is like an array, really. So autobiographical. What was it? Okay, so that's an interesting way of thinking about things. So we have. So how would I look through this? There's only one correct answer. Every subsequent position, a digit at a position n indicates how many times the digit n occurs in that array. So there's always the brute force way, right? You could just try every number and see if it's you could have like a check if it is autobiographical. That seems like it would take a long time. It'd be 10 to the 10. First, I'm going to make a function that checks to see if it's autobiographical. So let's do that first. So function is autobiographical. It will take an array, and it will just say true or false if it's autobiographical. So I think the idea here is I'm going to toss everything into a hash map and then keep a count of each integer, and then use that to declare whether or not the array is autobiographical. So let's do that. Store. I'm going to call it hash. Hash equals an object, and for const num of array. So I need to go through this at least once. I'm going to say hash of the num. So just to be clear, this is like the key equals the number in array, and the value equals the count of that number. Right, okay. So if you've never seen the number before, you're going to equal to yourself. And if you haven't seen it, you give a 0. And I just plus 1 on that. Okay. And then I will loop through the array. So I'm making note of big O notation here. So this is full of n. So for const num of array, after you go through it once, you can say, hey, the count equals hash of the num. If the the index. Sorry, I need to go through the I. So let I equal 0. So the number is actually do that. So number is actually the element itself that you're supposed to be. So the count is supposed to be the same as the array I. It's supposed to equal the count, right? So when this is not the case, I can return false. Otherwise, when I get through the whole thing, I can return true. And I need to make sure that if this is empty, I can return 0 because it's the same thing. If it doesn't exist, then it's a 0. And that will be the count. Okay, cool. So let me just do a quick check to see that autobiographical. I gotta copy this name. console.log array of like just a bunch of zeros, and running it in Node. Challenge, I call this one TED code. I get a false there, and otherwise I should get a, so 1 2 1 0 2 1 0. That should give me a true. So let's get it back here. Hey, it works. All right, cool. You go down to 0. So you start with the 10. You start with the 10th position. You cannot have, sorry, I mean the 9th position, position 9. So you go to the 9th position. There is no way you can have a 9 in the set, right? Because that would be like at least that would be a violation, because if there's a 9, then that means there's not 9 of something else. So 9 cannot possibly show up. So you can start backwards. So here's my strategy. We're gonna be, this is the iterative approach. Iterative. You loop backward since last digit must be 0. This is by the laws of logic. Okay, so let's go with 1 2 3 4. This must be 0. So you can step back one more and say, okay, can anything be 8? So at this point, you're accruing zeros, right? So this is at least a 1 0. So this will go up by 1. Then you get an 8. There are no 8s. So basically, you need to come to a point where this crosses the line. I think that's what we see here, right? Yeah, but anyway, you kind of see the same thing here, where like the 3 is like the cutoff point here. So I think you just keep going, loop backwards, and stop when 0 count is index, then bounce around logic. You keep increasing the 0 position to 1, then you get to the 8, it goes up to 2. It's like self-violating at that point. So you'd say, okay, 5 is where I'm at, so this is now a 1. This 1 is now here, so this becomes a 1. Now 1 there are 2 1s, so you have 2 here, you have 1 2 here, and you still have 2 1s. There are 0 4s, there are 0 3s, and there are still 5 zeros. So wait, is this the number? Wait, did I just find the number? So I actually just checked this on is autobiographical, and it is not autobiographical. So this is not the solution, and my logic for coming to it is not correct. I kind of want to go dig into why that is. There are 5 zeros, 1 2 3 4 5 6 zeros. So actually, it clearly isn't right. So this number should be a 6 then, which means that this number should be a 1. Now there are 0 5s. So it seems like there's like a lot of like finagling here. Wait a second, is this it? Oh wait, is this it? Oh my goodness. Did I just have to like finagle it a little bit more? Okay, let's see. Oh my god, I found it. Oh, I used my logical reasoning for that though. Oh, that sucks. I wanted to use code. I will still, so at least I kind of have an answer, which is nice to see. So I'm gonna like comment. So I do have a solution, which is nice to know what it is already. But I just use like logical reasoning to get there. Yeah, let's make a function. Why not? So I want to get the autobiographical. And I provided n here of the size of the array. And that's what we do. Const array equals new array size n filled with zeros. And here I will loop backwards. So the way I did this, I want to go back to like how I started out. Okay. So I literally went backwards until my zeros lined up, right? So I got to like 5. At that point, my 5s is the I, so that's where my I is at that point. It's at the 5, right? That's when I stop and I say, okay, this is now a 1. So what do? Okay, I'm back, and it's a little bit later in the day, but I just spent like the last 5 minutes actually going back to my code, and I made a, I would say, fairly small change, but I do want to go through it. So basically what I ended up doing was I realized that what I was doing before was I was only adding when I was adding to the queue, I was only adding one of the problems, but anything that changes needs to be added. So I check each one. So I want to run through this one time just to kind of show you how this goes. So basically the same logic is there. It's nothing too different. I still come in, I create an array that's filled with zeros. I start my I from the end. I loop through it until I get to the stopping point, and at that point I have the I, which is not really necessary at that point. I was just using it to get the 0th position, the 0th index, to the right number. In this case, it would be 5 in this case. So actually, let me come and bring this down. So this is basically the place that the array is in at the moment. And I start my queue with the 0th because that's the only thing that we'll be working with at that point. So you start with 0, you pop it off, you get 0 here. You create your hash, run through everything. In this case, it would be very simple because there's only really a bunch of zeros and a 5. And here's where I had to do a little bit of change. So I have my count still, and I need to capture the current value. This is just for convenience, really, but you have your current value here. You capture it, and if your current value is not properly set as the count for that index, that's the only situation where you need to worry about, oh, things are changing. That's when I need to add things to the queue to check. When you do that, you can definitely, because I've set all these variables up, I don't need to the order really doesn't matter too much here, but effectively I set the proper value to the index, which is the count that I found in the hash map. Then I push everything that was that potentially has changed and needs to be checked, and that gets added to the queue. So for every discrepancy I find, I add 3 values to the queue. Some of them may be redundant, and I can certainly put a check for that, but I didn't feel I need to. It's pretty quick otherwise. And then once that goes through, the length of the queue will eventually hit 0 because you will have found a good arrangement where there are no values that are out of place, and then you return the array. So let's look what this looks like. So here's my solution. I'm trying to get it all on one screen, so hopefully you can see all that. I think I might actually just post this in a GitHub just because why not? And the Monte Carlo definitely does not work, but let's see what calling the function will give us. It should be this 6210001 thing. Okay, so let me save. Let's call this thing up. And sure enough, it is able to use logical reasoning to create this. And the beauty of this, and that's kind of the reason why I want to code it out, is that this is set up for any arbitrary length of array. So they gave us 10 as a specific number, but I could get 11 if I really wanted to and get that. And apparently that's one of the ones that would be an array for 11, which actually doesn't look very different actually now that I think about it. Anyway, so this is effectively solved. So I want to go into the video.
The digit corresponding to that position occurs within the graphical. Since each individual already have, to see what kinds of patterns we can find. By adding all the digits in 1210 together, we get 4, the total number of digits. This makes sense, since each individual digit tells us the number of times a specific digit occurs within the total.
That makes sense.
So the digits in our 10-digit autobiographical number must add up to 10.
I didn't think about that. That makes sense.
This tells us another important thing. The number can't have too many large digits. For example, if it included a 6 and a 7, then some digit would have to appear 6 times, and another digit 7 times, making more than 10 digits. We can conclude that there can be no more than 1 digit greater than 5 in the entire sequence. So out of the 4 digits 6, 7, 8, and 9, only 1, if any, will make the cut. And there will be zeros in the positions corresponding to the numbers that aren't used.
Yeah, I figured that out early on.
So now we know that our number must contain at least 3 zeros, which also means that the leading digit must be 3 or greater. Now, while this first digit counts the number of zeros, every digit after it counts how many times a particular non-zero digit occurs. If we add together all the digits besides the first one, and remember, zeros don't increase the sum, we get a count of how many non-zero digits appear in the sequence, including that leading digit. For example,
Uh-huh.
if we try this with the first code, we get 2 plus 1 equals 3 digits. Now, if we subtract 1, we have a count of how many non-zero digits there are after the first digit, 2 in our example. Why go through all that? Well, we now know something important. The total quantity of non-zero digits that occur after the first digit is equal to the sum of these digits minus 1. And how can you get a distribution where the sum is exactly 1 greater than the number of non-zero positive integers being added together? The only way is for one of the addends to be a 2, and the rest 1s. How many 1s? Turns out there can only be 2. Any more would require additional digits, like 3 or 4, to count them.
Okay.
So now we have the leading digit of 3 or greater counting the zeros, a 2 counting the 1s, and 2 1s, one to count the 2s, and another to count the leading digit. And speaking of that, it's time to find out what the leading digit is. Since we know that the...
Okay, I just want to take a step back. So that's actually the pattern we were seeing here, which is effectively like after this length, there's always going to be a number, a 2 and 2 1s. That's effectively like the pattern that we were seeing. So now I understand why that is. I didn't think anything of it before.
The 2 and the double 1s have a sum of 4. We can subtract that from 10 to get
6. Oh, there you go.
Now it's just a matter of putting them all in place.
Holy crap.
6 zeros, 2
1,
1 2,
and at the 6.
0 3s, 0 4s, 0 5s, 1 6, 0 7s, 0 8s, and 0 9s. The safe swings open.
Yeah, just to like reconfirm that, like basically any number I put in here would be, if I put like 20, right, it would be the exact same pattern, right? Yeah, it's just 6 2 1 and 16 2 1 and then a bunch of zeros and a 1. Holy moly. And actually,
and inside you find Da Vinci's
it's 3 zeros at the end, so
lost autobiography. For today's bonus riddle, here's what we'd like you to do.
Oh no.
Find all of the autobiographical numbers. If you're not sure where to start, our partners at brilliant.org.
Okay. Okay, cool. So that was actually kind of interesting. I thought it's kind of funny, like having the mentality of just programming it versus like having to deduce it. So I actually came up with the answer just like going through the logic of how I would code it out, and I didn't really understand necessarily like, oh, there needs to be like, the first one needs to be greater than 3, and like I didn't figure that out, or the 2 1 1 pattern thing. I didn't know about that. I didn't care about it because the code kind of like brings it out already. So I thought that was kind of cool. Anyway, hopefully that was interesting and fun. If you like this kind of content, definitely leave a like or subscribe, and let me know in the comments what kind of stuff you'd like to see. Or maybe you have your own riddle. I'd be interested to see what that looks like. Anyway, I will see you next time. Have a great day. Bye.